For those of us in the data world, we've gotten really, really good at managing the what, all those terabytes of raw facts we store and query every single day. But what if the real treasure isn't in the data itself? What if it's buried in the knowledge, hidden deep inside? That's the challenge we're going to dig into. Right. That's the big question, isn't it? We are absolute pros at handling data, but how do we start managing the rich, hidden knowledge that's inside all that data? I'm not just talking about the facts, but the insights, the trends, the actual intelligence they represent. To get there, we first need to get our heads around a really powerful idea. And that idea is the pattern. Now, when I say pattern, I don't just mean a repeating design. In this world, a pattern is a powerful piece of knowledge. Think of it like a super condensed, really meaningful summary of a massive amount of raw data. Its whole job is to bring new, hidden knowledge to the surface, stuff you'd never ever see just by looking at one record at a time. And making this distinction is absolutely crucial. See, raw data is just a huge pile of low-level facts. It tells you what is. Patterns, on the other hand, are concise, high-level knowledge that tell you what it means. A pattern is designed from the get-go to be actionable and easy to understand. It's the difference between having a list of every single item from every grocery trip ever and knowing that people who buy bread also tend to buy milk. See the difference? So what do these things actually look like out in the wild? Well, they come in a lot of different flavors. You've got things like clusters, which are great for grouping similar data points. Think customer segmentation. Then there are frequent item sets, which tell you what things often show up together. You even see symptom diagnosis correlations in medical data. But for today, let's just zoom in on one of the most common types. Let's talk about the classic association rule, the one made famous by market basket analysis. This simple little rule here, bread implies milk, is a pattern. It's a tiny nugget of knowledge that's been mined from maybe thousands or even millions of shopping transactions. It suggests there's a connection, a behavior that we can now start to analyze. But for a pattern to actually be useful, we have to know how strong it is, how reliable it is. And that's where quality measures come into play. The first one is called support, and all it does is answer one simple question: how frequent is this pattern? Support tells us the percentage of all transactions where bread and milk were bought in the same basket. If the support is high, it means this combination isn't just some random fluke. It's something that happens pretty often in our data. The second measure is confidence, and it answers a totally different question. How reliable is this connection? Confidence is the percentage of people who, after they already put bread in their cart, also decided to grab some milk. High confidence suggests a really strong predictive link. If you see bread, there's a good chance you'll see milk. So remember, support is about frequency, confidence is about reliability. Okay, I know what you're thinking, especially if you have a database background. You're looking at this and going, okay, we've got these rules, they have numbers like support and confidence. Why can't we just spin up a table and stuff them in our good old relational database? It seems like it should be simple, right? But it's actually way more complicated than that. And the reason is, traditional databases just aren't built for this kind of work. Their rigid, table-based structure really struggles to store these complex and varied pattern types. And standard SQL, it can't really query their meaning. You can't just write a simple query for all rules involving bread. That's why we have specialized systems called pattern-based management systems, or a PBMS. They are designed from the ground up to do this stuff. They store patterns natively, they support these kinds of deep semantic queries, and they manage the entire lifecycle of a pattern, all while keeping that critical link back to the original data. So this brings us to what we call the pattern lifecycle, which is exactly what a PBMS is built to handle. It's basically got 4 key stages. First, you have extraction. This is where data mining algorithms go to work on the raw data to find and generate the patterns. Second is storage, where those patterns get saved in a specialized repository that actually understands what they are. Third is manipulation, because patterns aren't static, right? As your data changes, you have to update them or get rid of old ones. And finally, there's querying, the whole point of this, which is retrieving the patterns and connecting them back to the source data to get insights. Now, when it comes to actually building these systems, there are really 2 main schools of thought. On one hand, you have the integrated architecture, which tries to manage both the raw data and the patterns all in the same system. It's really tightly coupled, but the downside is patterns can sometimes feel like second-class citizens. On the other hand, there's the separated architecture. This uses 2 completely distinct systems, one for data and a specialized one for patterns. This gives you way more power to express complex patterns, but then you have to write these tricky crossover queries to link the 2 worlds together. As always, it's a game of trade-offs. And that really brings us back to where we started. We're talking about a shift from just managing data to managing the knowledge that's inside it. Which leads me to a final question for you. What valuable, actionable patterns are just sitting there, dormant, in your data, just waiting for the right system to unlock them? If you found this useful, do me a favor and hit that like button, share it with someone, and subscribe for more explainers just like this one.